Welcome to the Smartboard. In this example, we're going to take a look at what a greenhouse actually makes a greenhouse. I guess you all know what a greenhouse does. It is glass surrounding an area to make it warmer inside. In parts far away from the equator, people use it for agricultural reasons to avoid that it's too cold outside and the crops don't grow. What is the trick here? Why does that work? All right, let's think about what happens. Here is my greenhouse. And here is not my greenhouse. A very basic simple model goes as follows. The sun radiates in, so there's a heat flux from the sun coming in. The earth radiates back. This is the only way that the earth gets heat up and the only way that it can prevent itself from cooking. So if we do the most simple idea, the most simple model, we say that the earth is by and large in a steady state. So the amount of solar energy coming in, which is over an area, the projection of the earth as a disk to the sun, is balanced by what goes out, which goes out over the entire radius, the entire sphere of the earth, times the black body radiation of the earth. T of the earth to the power 4 times sigma. The idea here is, it's not so difficult to grasp. The earth is a sphere and it radiates in all directions as a sphere, but for the incoming solar radiation, basically the projection of the earth in the path of that radiation is the area that captures all the incoming energy, all the light coming in. That's the difference, that factor of 4. This one is 1400 watt per square meter. Outside the atmosphere, we completely ignore atmosphere, we ignore clouds that radiate away, we ignore radiation from the poles where the frozen poles, the ice radiates. So the most simple one, it's pretty basic, it's not accurate, but it's good enough to illustrate the point later on. If you do that, then you will get that the Earth's temperature is 280 Kelvin if you compute this, which is not too bad at all. So order of magnitude is pretty good. Okay, what changes if we're going to look at the greenhouse? Well, the solar light is by and large coming in, reaching the greenhouse. The greenhouse is going to radiate back. But this solar light is of a wavelength for which, to a first order approximation, the glass of the greenhouse is transparent. So all the energy comes in. That is not the case with the radiation from the Earth back. That is in the infrared. And glass is not transparent for infrared. So the simplest model that we can make, that we say glass is absolutely not transparent. So the radiation here will be absorbed, that comes in by the glass, it cannot escape, will heat up the glass, and that glass will start radiating, and here the fun begins. Because that glass radiates in two directions. Okay, let me give this some names. Incoming solar, temperature of the earth, the temperature of the ground in the greenhouse, which will heat up the entire greenhouse. And then that roof will have, that glass will also have a temperature, Tg, at which it starts radiating back. This changes. Because now if I look at the earth here, to find the temperature Te, still, this comes in per square meter. So if I do as if the entire Earth is a greenhouse, just to keep life simple and to be as close as possible to this, it's not true of course, but you get the picture, I hope. Then it radiates back, But it's not the same temperature, so I'll put a tilde on it. Because an additional term comes in, which is 4 pi Re squared, because we covered the entire Earth with a greenhouse glass plates, almost at the Earth, of course, just here, and have to multiply that by the glass plate temperature to the power 4. Shoot. This is an equation with 2 unknowns, but that's not too bad at all. I can also equate that in steady state, these glass plates are in equilibrium. So the incoming radiation for the glass plate, which is just what the Earth radiates, it's all absorbed here. And 2 of these terms go out as far as the plate is concerned. Right? So what do I see? Let me flip to yellow again. This term, which is extra, in the case of the greenhouse that we constructed all around the globe, is actually, there's a factor of 2 here, is half this one. So the net effect of these two is that it reduces the outflow of the Earth by a factor of half. So in my very coarse basic model, I get that 0 equals the influx from the sun minus a half 4 pi Re squared sigma, the new temperature of the Earth. I can solve this equation, and that's pretty straightforward because it gives the same solution as here, except for this factor 2 to the power 1/4, so it doesn't go that fast. And if you equate that, let me peek on my piece of paper, there is an additional factor of 1.18 in the temperature of the Earth. So if I write that in a more neat way, the greenhouse that we made by putting this glass around it gives you an Earth temperature that is about 20% higher than the greenhouse without, the Earth without greenhouse, which is pretty significant. It's going to heat up the Earth to about 80 degrees Celsius. Yeah. Compared to what we had here, 7 degrees Celsius. Gives you a bit of feeling why we need to worry about the greenhouse effect with our CO2. Because actually, our atmosphere is playing this glass plate. Now, it's not that severe because we have a very, very simple model, but you see here the action of greenhouse gases. Try and model this better yourself. Take a look at the internet and you will find how to change this, how to bring into account that there are clouds, how to deal with the greenhouse, and you will see that if you do that, then it's pretty fine. If you want to improve, check out on the internet how you can bring in the effect of clouds, albedo, the reflection of the Earth, how you can deal better with the layer itself and its absorption. And you will find that indeed still CO2 and other greenhouse gases kind of are a layer that absorbs some of the radiation coming out of the Earth and radiate back to us. The atmosphere does so always, luckily, otherwise it will be very cold on the Earth. But we are playing a dangerous game with our greenhouse effect and the greenhouse gases. Good luck.